Hello everyone, myself Pooja, studying MSc in Computer Science at Mansanagotri, Mysore, and my topic is error detecting techniques. Before going to explain about error detecting techniques, we should know about the definition of error detection. And error detection, it is nothing but when data is transmitted from one device to another device, the system does not guarantee whether the data received by the device is identical to the data transmitted by the another device. An error is a situation when the message received at the receiver end is not identical to the message transmitted, which is nothing but error detection, which is nothing but an error is a situation when the message received by the receiver end is not identical to the message transmitted. And now we can see error detecting techniques. The most popular error detecting techniques are four. 1. Single parity check. Second, two-dimensional parity check. Third one, checksum. Fourth one, cyclic redundancy check. Now we are going to see about single parity check. Single parity check, it is nothing but single parity checking is the simple mechanism and expensive to detect the errors. In these techniques, a redundant bit is also known as parity bit, which is appended at the end of the data unit so that the number of ones becomes even. Therefore, the total number of transmitted bits would be 9 bits. If the number of ones bits is odd, then parity bit 1 is appended, and if the number of ones bits is even, then parity bit 0 is appended at the end of the data unit. At the receiving end, the parity bit is calculated from the received data bits and compared with the received parity bit. This technique generates the total number of ones even, so it is known as even parity checking. This is about single parity check. And now in this diagram, uh, whichever I am discussed about the single parity check, it is all explained in this diagram. And then moving to the drawbacks of single parity check, there are two drawbacks of single parity check. One, it can only detect single bit errors, which are very rare. And second one, if two bits are interchanged, then it cannot detect the errors. These are all the drawbacks of single parity check. Moving to two-dimensional parity check, performance can be improved by using two-dimensional parity checks, which organize the data in the form of a table. Secondly, parity checks bits are computed for each row, which is equivalent to the single parity check. Thirdly, in two-dimensional parity check, a block of bits is divided into rows, and the redundant row of bits is added to the whole block. And coming to the next point, at the receiving end, the parity bits are compared with the parity bits computed from the received data. This is about the two-dimensional parity check, and this is the explanation by the diagram. And moving to drawbacks. Drawbacks of 2D parity checks are there are two drawbacks. Firstly, if two bits in one data unit are corrupted and two bits exactly the same position in another data unit are also corrupted, then 2D parity checker will not be able to detect the error. This is the main drawback of 2D parity check. And coming to the second drawback of the 2D parity check, this technique cannot be used to detect the 4-bit errors or more in some cases. And these are all about the drawbacks of 2D parity check. And coming to the third techniques of the error detecting technique, checksum, which is nothing but checksum. A checksum is an error detection technique based on the concept of redundancy. It is divided into two parts. First, checksum generated. Firstly, we are going to discuss about the checksum generator. A checksum is generated at the sending side. Checksum generated subdivides the data into equal segments of n bits each, and all these segments are added together by using one's complement arithmetic. The sum is complemented and appended to the original data known as checksum field. The extended data is transmitted across the network, and this is about the checksum generated. Suppose L is the total sum of the data segment, then the checksum should would be, yeah, and then this is the diagram which is going to explain about the checksum generator, and then there will be some steps which must and should follow by the sender. The sender follows the given step. Those are: the block unit is divided into k section and each of n bits. This is the first step. Coming to second step, all the k sections are added together by using one's complement to get. And third one, the sum is complemented and it becomes the checksum field. And the fourth one is the original data and checksum field are sent across the network. These are all the fourth steps which must and should follow by the sender. And second one is checksum checker. This is all about the checksum generator, and now we are going to see about the checksum checker. And checksum is verified at the receiving side. The receiver subdivides the incoming data into equal segments of n bits each, and all these segments are added together, and then this sum is complemented. If the complement of the sum is 0, then the data is accepted, otherwise the data is rejected. Then as the sender must follow the steps, and also the receiver must follow some steps which are nothing but: the block unit is divided into k section and each of n bits. All the k sections are added together by using one's complement algorithm. The sum is complemented. And the last one is, if the resultant of the sum is 0, then the data is accepted, otherwise the data will not accepted. And then the fourth technique of error detecting technique is cyclic redundancy check, which is nothing but CRC. Short, you can call it as shortcutly CRC, which is nothing but cyclic redundancy check. The cyclic redundancy check is a redundancy error technique used to determine the error. This is the definition of the cyclic redundancy check, which is: cyclic redundancy check is a redundancy error technique used to determine the error. Following are the steps used in cyclic redundancy check for the error detection. Those are: in cyclic redundancy check technique, a string of n zeros is appended to the data unit, and this n number is less than the number of bits in a predetermined number known as division, which is n plus 1 bits. And secondly, the newly extended data is divided by a divisor using a process which is known as binary division. The remainder generated from this division is known as cyclic redundancy check remainder. Thirdly, the cyclic redundancy check remainder replaces the appended zeros at the end of the original data. This newly generated unit is sent to the receiver. And fourthly, the receiver receives the data followed by the cyclic redundancy check remainder. The receiver will treat the whole unit as a single unit, and it is divided by the same divisor that was used to find the cyclic redundancy check remainder. If the resultant of the division is 0, which means that it has no error and data is accepted. If the resultant of this division is non-zero, which means that the data consists of an error, therefore the data is discarded. In this diagram, they explain about the cyclic redundancy check, and these are all about the error detecting techniques. And thank you.